Number 8 is really similar to number 6, so hopefully you got help on that one if you needed it. But this time it says x is the hypotenuse, which means x should be on its own side of the equal sign. I don't have a lot of space for this, so what I am going to do is I'm just going to go down to the end where I do have space. And I'm going to do it down here. So these are my side lengths. I'm going to use x as my hypotenuse. It's a triangle, so I'm using a right triangle. I'm going to use my Pythagorean theorem. X is the hypotenuse, so that's what goes in for C. And just like on number 6, you have to square the entire number you plug in. Don't forget to do that. It is tedious, especially if you always just do the write it twice method. So I'm going to get 3 times 3, root 2 times root 2. The square root of 4 is a 2, so I end up at regular 18. But I'll have to also add on whatever 6 root 2 squared is. So that means 6 root 2 times itself. 6 times 6 is 36. Root 2 times root 2 is square root 4. But I know the square root of 4 is the number 2. So all that just turns out to be 18 plus 72. So 90 is on the other side of the equal sign. Oops. Let me try again. So I have that equal to x squared. Sorry, I'm just trying to fill in all the x squareds just to make it clearer if you just look at the answer key. But that doesn't find me x yet. So instead of x squared, I need to get rid of it by a square root, not a divide by 2. That's not a perfect square, unfortunately, but I can find some perfect squares inside. Instead of the square root of 90, I could have thought of that as the square root of 2 times 3 times 3 times 5. Pairs make perfect squares. That's a square root 9. But I know the square root of 9 is a regular 3. I don't have anyone to pair the 2 and the 5 with, so they're just going to get multiplied back together. 3 root 10 would be the length of the hypotenuse. So that's what I would have for, I think I just did number 8.